Hi there, let's cover problem solving using rates and dimensional analysis. This is where we left off with the last video, so I just want to make sure you're good with this going forward. Let me get my pen set up here, so sorry. Thought I had it set up. I do, okay. So, all right, there it goes. So we're going to start off with the definition of a rate. And a rate is just a ratio that compares two quantities with different rates. And I will give you examples of this as well. So it's just two quantities. That's a ratio that compares. I'm going to have to move my thing here. It's a ratio that compares two quantities with different unit rates. And we haven't defined unit rates yet, but we'll do that next. With compares two quantities with different units. Oh, with different units. Why I'm not focusing. Units. Okay. Moving on to the next one. What is a unit rate? A unit rate is a rate that has 1 as the denominator. So it's the number in the bottom part of a fraction. It's a rate that compares to, that has 1 as denominator and that's it. So examples of this. Let's do an example. So 24 pencils cost $1.20. All right. Price per pencil. So if I tell you or they tell you price per pencil, well, what does that look like? That means the price is in the numerator per the number of pencils for the rate. So it would be $1.20 for the rate. Would be $1.20 because that's the price per, and there's 24 pencils. The unit rate would be dividing these. So you would end up with a 1 in the denominator. So sorry. We got cats and I don't think that's going to work. The unit rate would be taking the $1.20 in a calculator and divide it by 24, and you would get 5 cents per pencil for one pencil. Notice there's a 1 in the denominator. Okay. You could also write it 5 cents per pencil. Okay. So now you have a rate, which is the $1.20 divided by 24 pencils, and then the unit rate, and I should say that is the unit rate, is 5 cents per one pencil. All right, let's move on. Nat's car can drive 300 miles on a tank of 15 gallons. Okay. Express this as a rate and as a unit rate in miles per gallon. So miles per gallon. So we're going to look at doing this at miles per gallon. So that just means you need to have the miles in the numerator. So 300 miles divided by gallons, which is 15 gallons. All right, and that is your rate. So expressed as a rate. There's your rate. The unit rate is just dividing those. So 300 divided by 15 is 20. So it would be the unit rate would be 20 miles per 1 gallon. Or you could say 20 miles per gallon, or you could say 20 mpgs because that's how we use it as well. So you have the rate, and you have the unit rate. We're golden there. Moving on. Yeah, you're going to want to write a sentence. The rate is 300 miles per 15 gallon. The unit rate is 20 miles per gallon. You could write any of those three that are above there, though. They'd be totally fine. All right, Nat's car can drive 300 miles on a tank of 15 gallons. We know that. How far can it drive on 40 gallons? Okay, well, what did we just have? That it goes, let's look at that real quick. I think it said 20 miles per gallon, didn't it? Sure as heck did. So if it goes 20 miles per gallon, let's go back to that. Our car can go 20 miles per gallon. Well, notice gallon is in the denominator. So we can just put gallons in the numerator. All right, so that's times, this is just converting, times 40 gallons. Okay, when we do that, gallons are gone when you multiply straight across and you get 800 miles. All right, so she can go 800 miles on 40 gallons. So Nat can drive, how far can it drive on 40 gallons? Nat can drive 800 miles on 40 gallons. How many gallons are needed to drive 50 miles? Okay, so we're going to want to know what the gallons are. Well, right now we have miles in the numerator, miles per gallon. But one of the really cool things with this is you can flip those, because this is just like saying 20 miles is equal to 1 gallon. Well, that just means I can write that 1 gallon is also 20 miles. Okay, so if we do that, we can just multiply. How many gallons are needed to drive 50 miles? Well, miles is now currently in our denominator. So if we put 50 miles times 50 miles, we're going to get the number of gallons, because when you multiply straight across, your miles are gone. Okay, so that would be 50. 1 times 50 is 50, divided by 20, and this is gallons. All right, that looks to be about 2.5, but I want to check my numbers here. 2.5. All right, so this is equal to 2.5 gallons. So how many gallons are needed to drive 50 miles? 2.5 gallons are needed. 2.5 gallons are needed to drive 50 miles. All right, moving on. A bicycle is traveling at 15 miles per hour. How many feet will it cover in 20 seconds? Okay, so we're going to be multiplying by 20 seconds. So we're going to want seconds in our denominator. Hold on, they also want it in feet and not miles. Oh, okay. I didn't leave myself a lot of room here. So 15 miles per gallon, per hour, so sorry, times, we're going to need some conversions here. Because we're going to need to go from miles to feet. And there, if you look at your conversion chart on the left-hand side for the US, you'll see that I think I had it under is furlong, or yeah, where it says 8 furlong, I kind of moved that over and moved it 1 mile equals 5280 feet is equal to 8 furlongs. So 1 mile is 5280 feet, 5,280 feet. 1 mile is equal to 5,280 feet. What else do we need? We need to go from hours to seconds. Okay. So 1 hour, we can't go directly to seconds, but we can go to minutes. And then we can go from minutes to hours. So think of the puzzle. So 1 minute is equal to 60 seconds. All right, let's convert. Let's start with our miles. It doesn't matter which one you start with. I'm just going to start with my miles. I always start with my numerator. Miles is in my numerator, so I need miles in my denominator and feet in my numerator. So that's 5281. All right, so miles are gone. And then hours, I have to go from my hours is in my denominator. So I need hours in my numerator and minutes in my denominator, but I need one more to go from minutes to seconds. Okay, so when I do that, there's 1 hour, 60 minutes, 1 minute is 60 seconds, multiplying straight across. Miles are gone, hours are gone, minutes are gone. We're down to feet per second, which is what our goal is. So when we multiply this 15 times 5,280 times 1 times 1, okay, what do we get? I didn't do my, well, I'm going to pause real quick. Okay, whipped out the trusty calculator. So I got 79,200 on my little thing here. All right. So that's 79,000 on my computer here. 79,200 feet divided by 1 times 1 times 60 times 60 is 3,600. And this is seconds. Now we divide. And we get 22. So there's 22 feet per 1 second. But the question is, how many feet will it cover in 20 seconds? So we have to multiply by 20 seconds. Seconds is in our denominator, so it definitely want seconds in our numerator. So 22 times 20 will give us the total, because when we multiply straight across, seconds are gone. And we get 440 feet. All right. So how many feet will it cover in 20 seconds? The bicycle will cover, so if we can do this, the bicycle will cover 440 feet in 20 seconds. Okay. Note that this problem could be broken into multiple steps. I don't like to do that. I find that more mistakes happen in that case. Without rounding the answer each time. And also remember, you don't ever round until you get your final answer in this class. Or done in one long conversion like I just did. I tend to do the longer conversions so I don't have to worry about rounding or weird fractions, but I will follow your logic, do what makes sense to you. Okay. Okay, I think we just did that. Oh, shoot. That was where I could have done it. Okay. Now I was walking through a hardware store and noticed 2 sales on tubing. 3 yards of tubing A costs $5.49. I'm going to write this down. Let's see here. Tubing A costs $5.49. Tubing B sells for $1.88 for 2 feet. Okay, so I like to do price per foot. That's how I like to check things out. So I'm going to put $5.49 per 3 yards, because then I can always convert to find out what I need based on the length. That's tubing A. Tubing B sells for $1.88 for 2 feet. Either tubing is acceptable for her project. Which tubing is less expensive? Well, we have to have them in the same unit to even begin to compare which was less expensive. So let's just take our yards to feet. It's going to be easier, I guess, to see that. So let's look at that. So there are, if you use your unit conversions, your useful conversions on the left-hand side of the US version, it has under the length, one yard is equal to 3 feet. Okay, so So we're going to convert this one. We have yards in my denominator. We need yards in the numerator, feet in the denominator. 3 and 1, multiplying straight across. 549 times 1 is 549. Divided by 3 times 3 is 9. And this is yards per, no, not yards. Oh gosh, hold on. It's dollars. I'm losing my mind. Eraser. Erase all this. Okay. Let's try this again. All right, so that's dollars per feet because our yards went away when we multiplied it. All right, so now we just need to use our trusty calculator and do 549 divided by 3, and we get 61 cents per foot. Okay. The next one is $1.88 for 2 feet. Well, the other one has foot, this one has 2 feet, so let's just get rid of the 2. So this is equal to, which means you just have to divide $1.88 divided by 2 to find the unit price, which is what we're doing for both of these. And that ends up being 94 cents per foot. So now we can easily see that tubing A is less expensive then you can always find that out too, by how much, just by subtracting them. So that's something I would probably ask you in a test is which one is less expensive or more expensive and by how much? And if I ask you that, you're going to want to subtract 94 cents and 61 cents and get 33 cents. So tubing A is less expensive by 33 cents than tubing B, or 33 cents per foot. We can just leave it like that, per foot. That answers the question. All right. At this, complete you try 2.6. Before I come back to class, this is something I would have asked you. Example 22, the cost of gasoline in Western New York is about $3.46 per gallon. When Nat travels over the border into Mexico, gas costs 17.83 pesos per liter. Where is gasoline more expensive? Note the problem requires a currency conversion factor. Currency conversions are constantly changing, but at the time of Nat's trip, which was in January 6th of this year, it was $1 for 21.51 pesos. All right, so we need to convert. If you look on your right-hand side of your useful conversion chart, you will see under capacity, 3.79 liters is equal to 1 gallon. So 3.79 liters is equal to 1 gallon. And that's what we're going to use for our conversion, along with the $1 is equal to 20.51 pesos. Those are our two conversions we'll be using. All right, and we're going to have to do both of them. So we're going to have to, well, let's just get into something we're used to. Let's just go $3.46 per gallon. We'll stick with that one. And then we'll convert the pesos per liter to dollars per gallon because that's something we can understand. I'm fine with you going the other direction too. They're both fine. So $3.46 per gallon. The other one is 17.83 pesos per liter. We have two conversions to make here. We need to go from pesos to dollar, and from liter to gallons. This is liter here. All right, so pesos to dollars is 20.51 pesos to $1. Liters and gallons, 1 gallon is 3.79 liters. So now we can multiply straight across. When we do so, the liters are gone, the pesos are gone, and we're left with dollars per gallon, which is what we're looking for. 17.83. Let's get my calculator. Times 1 times 3.79. 17.83 times 3.79. I got 67 point, and I would typically not write any of this down because it's ridiculous, but just so that you can can see it. I would typically go through and just divide by the 20.51 because that's the only thing in the denominator. But feel free, write everything down on the calculator that it says so that you're not rounding until you're done. It's dollars and gallons, 20.51. Now we can divide by the 20.51 and we get 3.294, let's just say $8 per 1 gallon. All right. United States rounds to the penny because that's our smallest unit of currency. So the penny takes residence in the second space to the right of decimal, the hundredths place. So when rounding money, you need to make sure and round to the penny. I will not say it on the exam. You are going to need to know this. Put it in your notes so that you know this. So if we're using 9 as our rounding digit, that means the number next to it is our test digit. If the number to the right of the rounding digit, the test digit, is greater than 4, then you would add 1 to your rounding digit. Okay, but in this case, it's not greater than 4, it is 4. So it doesn't affect the 9 whatsoever. So our answer is $3.29 per gallon. All right, now we can answer the question. Where is gasoline more expensive? Gasoline is more expensive in Western New York than in Mexico. Okay. Because it's $3.29 again. No, it's $3.46 a gallon, and in Mexico it's $3.29 a gallon. So definitely more expensive in Western New York. Note on number 22, the conversion between dollars and pesos. These exchange rates are constantly changing, daily in fact, especially right now through all the economic changes happening because of this crazy virus. All right, I'm going to stop this video, put it out there, and then I will do the you try problems.